In this video, we will be discussing how to create and address arrays and matrices and how to perform the different mathematical operations with them. Arrays and matrices are fundamental form of MATLAB which are used to store and manipulate data, and there are various of methods to arrange the numbers in them in form of rows and columns. In MATLAB environment, every variable is an array or matrix. You can assign variables in a simple way. For example, let's have a look on the command window. Here we are typing x equal to 4. That is, we are defining x and initializing with a value equal to 4. So when you press enter and execute this statement, the above statement will give us the result x equal to 4 as displayed on the command window. So this will create a 1 cross 1 matrix named x, and it will store the value 4 in its element. You can have multiple assignments in the same line. For example, here we are typing a equal to 2, put a semicolon, b equal to 7, put a semicolon. So two statements can be written in the same line and they may be separated by semicolon. When this statement is executed, the a and b will be displayed on the workspace. However, because we have put a semicolon at the end, so the display will be suppressed at the command window, and you can still have a look on the values which are assigned to these two variables a and b or from the workspace. Let us take a sum of these two variables which are now stored in the workspace and store the result in another variable named c. So we are executing c equal to a plus b, and that will give us this result of the answer, that is c. There are many ways to create a vector. To create a row vector, type the elements with a space or a comma between the elements inside the square brackets. To create a column vector, type the brackets and then enter the elements with a semicolon between them. To create a row vector x with the entries 0, 1, 2, 3, 4, 5, there are two ways of doing it. We need to type all the elements of this vector within the square brackets separated by spaces, or we can enter the values by putting a comma between each of the element of this vector x. The other way of creating a row vector is with the increment based method, or the syntax that we need to use is in order to create the vector axis, we have to write the initial values, put a colon, write the increment, again put a colon, and the last value. That is, if we see the statement x equal to 0 colon 0.2 colon 1, it will be creating a vector, row vector of the values which will be stored in x with the initial value 0 and the final value 1 with an increment of 0.2. So we'll be getting the answer 0, 0.2, 0.4, 0.6, 0.8 and 1. Another way to create a row vector is to call inbuilt function linspace in MATLAB. The syntax is linspace a, b, n, where this linspace is the inbuilt function and it will generate a row vector of the points, n number of points, which will be linearly spaced between the initial starting value a and the final value b. So if we need to create a vector consisting of 6 points and we want the values in the interval 0 to 1, then we can create a row vector by calling linspace, and the syntax is linspace bracket 0, 1, 6, where 0 indicates the initial value, 1 indicates the final value, and 6 is the number of the points which will be created in this row vector. So when we use a linspace, it is actually creating the linear spacing between the values or the equal spacing between the values, and here we don't have to decide the increment will be automatically taken care by the linspace function that we are calling. In order to find the length of a vector, we can use the syntax length of x. So basically we are calling the inbuilt function length and we are operating this on the variable x. So that will give us the number of elements which are stored in the vector x. In order to find the size of the vector, we can call size of x, and this will give us the number of rows and columns in that vector. So these are the different means by which we can create a vector, that is a row vector. To create a column vector, we need to write all the entries of that column vector, and we need to separate all the entries by a semicolon. So that will create a column vector. To take a transpose of a vector, we need to put a dash after once the vector has been declared. So put a dash that will take the transpose of this vector. If it is a row vector, it will be converted to column vector and vice versa. So let us now execute all these statements in the command window and see what is being displayed. To enter a comment statement, we can put a % sign before the statement, and we can make this a statement now non-executable. So here we are writing a comment statement, % sign, then create row vector. Also you can see that whenever you are making any statement as a comment statement, it will be displayed in green color. So here we are executing all the statements that we have just discussed. So let us write on the command window. At the prompt, let us create a vector x1 with some entries in it, and we need to put all the entries into the square brackets. So all the entries, all the numbers has been separated by spaces. So when we execute this, x1 is displayed on the command window. Since the values has been stored in the variable x1, so we can see on the right side in the workspace, this variable x1 is being displayed. Also, we can create the same row vector by putting commas between all the numbers. So again, we find the same answer. To create a vector x2, we're using the increment formula. Let us create a vector with x2 with initial value 0 and the final value 1 with an increment or the step size of 0.2. So execute this, we'll be getting the 6 values displayed with a increment which is being set by a user, that is 0.1. If you don't put any increment in between, and you can simply write 0:1, so it will be taking the default increment of 1. So every value will be displayed with an addition of 1. The other option that we have just discussed is the length space of creating a vector. So length space will be creating the vector with equal spacing, and we can create the values, whatever values you want to create, and without being worried about what steps I should be taken between them. So length space will take care of that, and we are calling the function length space, and we want to create a vector of 6 values starting from 0 and ending up to 1, and we want an equal increment between them. So the syntax is length space, bracket, initial value, comma final value, comma number of points that we wish to create the vector. So when you execute this, you'll be getting the answer stored in the variable x3. Also at the workspace, you can see that we got the 6 values, and the increment has been automatically adjusted by the function length space. The length of the vector x3 can be determined using the keyword or the function length, and we can see that in the x3 we have 6 entries, or the 6 elements are there, and this gives us the answer 6. In order to find the size of this vector x3, we have to call size function, which will be operated on x3 vector, and this gives us the result 1 and 6, where the first value, that is 1, indicates the number of rows and 6 indicates the number of columns. Now here we have seen that we have used 3 inbuilt functions: length, space, length, and size. These are the inbuilt keywords or inbuilt functions that can be called to be operated on the variables or the data. Now all these keywords or the inbuilt function, they are written in the lowercase. Let us create matrix now. Matrix is a two-dimensional array. To create a matrix, let us denote this by A on the command window, and let us enter all the elements of this matrix. So in order to write the entries of all the matrix in this matrix, we need to first define all the elements of the row. So the row number 1 of this matrix A is having the entries 1, 2, 3, 4. So first we need to write all the values of the first row, put a semicolon after that, write all the values of the second row, put a semicolon, and then all the values of the third row. So this will create a vector with 3 rows and 4 columns. So let us execute and see what is being displayed here. So you can see here that we get a matrix of the values that we have defined for it, and the size of this matrix can be called or can be evaluated by calling the function size of A. That will give us the result 3, 4, where the first value 3 indicates the number of rows and the second value indicates the number of columns. Also in the workspace, you can see the matrix A has been displayed as the first variable and it's been written 3 cross 4. The size is written here 3 cross 4. The other way of creating a matrix is, suppose we want to create a special matrix that is an identity matrix, then a function I is available in MATLAB. So we'll be using I of 3. The syntax is I of n, where n will be n cross n identity matrix. So right now we want to just create an identity matrix of size 3 cross 3. So we need to write I of 3. So that will be creating a matrix of size 3 cross 3 with the entries of all the diagonal entries to be 1. Now here we have not assigned this answer I3 to any of the variable. So by default the word ANS or the variable ANS is displayed, which is the default variable name if we don't assign any variable to the answer. So here what we can do is, now suppose I wanted to save this as I of 3, I wanted to store in some variable. So I'm defining variable B and I'll be storing I of 3 in B. So I'll be calling ANS from the workspace and I'll be assigning that to the B with the syntax will be B equal to ANS. Then in order to create a matrix of random values, then we have rand function available. And we are creating here, by calling the rand, we are creating here the matrix of size 3 cross 3 of all the random values. Now when we call the rand command, rand is actually creating a matrix of random values with all the values lying between 0 and 1. Where the rand n cross n will indicate the size of the matrix. We can create any size matrix. If you want to create a size 3 cross 4, then we need to type here rand of 3, 4. Multiply matrix B and C and store the result in D. For that, we need to use the operator asterisk in order to carry out the multiplication of the two matrices. To find the inverse of a matrix, we can call the inbuilt function inv. We need to write this in lowercase, so we are calling inv of D. So I'm evaluating inverse of the matrix D and storing the result in D1. So when you execute this, the result of inverse is obtained and stored in D1. If we want to calculate the determinant of the matrix, then we need to call the keyword or the inbuilt function det of the matrix of which you want to calculate the determinant. So we are right now calculating det of D and storing the result in D2. Similarly, there are some special matrices like x equal to zeros 1, 4. This matrix will create a vector of one number of rows 1 and number of columns 4, and all the entries will be zeros. Similarly, there is another special matrix y equal to 1s 2, 3. We are calling the function once and we are operating on the index that we have given for the row and column is 2, 3, where 2 indicate the number of rows and 3 indicates the number of columns. So we wanted to create a matrix with 2 rows and 3 columns and all the values should be equal to 1. So for that we can utilize ones in order to get this type of result. Usually such type of matrices are required when we are taking some initialization problems where we need to first initialize some vector either to 0 or 1, then we can utilize these special matrices there. Here we are defining two matrices A and B and we are trying to compute the product of A and B using the multiplication operator of the matrices, that is asterisk. So A asterisk B will give us a product of the two matrices which will be stored in the variable ANS. Now suppose we want to perform the multiplication of the matrices in such a way that we want the element of one matrix to be multiplied by the element of another matrix situated at the same location, that is the same row and column. So that will be termed as the element-wise multiplication. To perform the element-wise multiplication, we need to put a dot before the operator, that is multiplication operator. So it will be dot and then the asterisk. So we have to write A dot asterisk B. So when we perform this and execute this statement, we get a different answer because this multiplication is the element-wise multiplication. Create a vector V with some value. Now create a vector W from the elements 3 through 7 of the vector v. So we can see here when we execute this statement, we need to write v3 colon 7. So the values will be read from the third element of the vector v up to the seventh element. So all these values will be entered and they will be saved in the vector w. In order to take element-wise division of this vector w, we need to write 1 upon w, but because we want to perform the division element-wise, so we need to put a dot before the operator, division operator, slash. So slash is the division operator, and if we want to perform element-wise division, then we need to put a dot before this operator, as we have done in the case of element-wise multiplication. So whenever we want to attempt an element-wise operation of the matrices, then we need to put a dot before the operator. The operator may be asterisk, which is used for multiplication. The operator may be slash, which is used for the division. So element-wise will be requiring a dot operator also needs to be put before the concerned element-wise operations. So here we are performing element-wise division of the vector w. So that gives an answer as shown here. Now let us create a vector f 1 colon 4. So when we write this in increment form, we have actually not given the step size of the increment. We have just written 1 colon 4. So it will be automatically taking the default increment of 1, where with the initial value will be 1 and the final value will be 4, and in between the values that will be getting will be having an increment of plus 1. So we have created a vector f from starting from 1 up to 4. Now we want to add some more values to this vector f, and we want to add 6 elements starting after the 5th. So in order to do that, we need to define here that we want to create 6 more values after 5th. So we are writing here 5 colon 10, and the values that we want is we want the values to be starting after this 10th value, and we want the values to have an increment of 5. So we can write 10 colon 5 colon 35. So the last value that we'll be getting will be up to 35. Now suppose we want to read a particular value of any of the vector or any of the matrix, we need to define the indices of the rows and column where we want to read that value. Suppose from this vector f, we want to read the 8th value. So we need to indicate that row and column number there. And suppose we want to modify this 8th value of this vector to some new value, that is we want to make it 12. So we need to write that index number and we need to write the value that we want to modify. So when we execute this statement, we can see that we will be getting a value modified as 12, which is our 8th value, that is the 25 will be modified to 12 as shown.